Don't forget to like and share this video. Today we are going to look at trigonometric ratios of complementary angles. Now, when sum of two angles add up to 90 degrees, we call it complementary angles. For example, 10 degrees and 80 degrees, they add up to 90 degrees, so they are complementary angles. We also have 70 degrees and 20 degrees. They also add up to be 90 degrees, and it is also complementary angles. So in relation to trigonometry, let's look at how this is applied in trigonometry. So we have right angle triangle. We have three interior angles over here, but one of it interior angle is 90 degrees. So the two unknown interior angles will be labeled as, so I will label here as theta, and I'll also label here as 90 minus theta, because before you get this angle, you must subtract whatever that this angle gives you from what we have here. Then you're going to get this particular angle. So this is what we are using to represent the angle. Now, in relation to the trig ratios, when you are asked to find sine theta, you know sine theta you can use so, and in terms of the cos, you can also use this. So for you to find sine theta, you know it is opposite over hypotenuse. So over here, what is the opposite? And find where the theta is. This is the theta, so this will be the opposite, and opposite will be the BC. And the hypotenuse is the longer side of the right angle triangle, and that will be AC. So in relation to cos, now we are not finding cos theta, but we are finding the other angle, which is cos 90 minus theta. So you know cos is A over H, adjacent over hypotenuse. And what is the adjacent? So you know, if we are using the angle 90 minus theta, then here will be the opposite to this angle. So our adjacent will be the BC. So BC over the hypotenuse, which is the AC. And you can compare the ratio of the sine theta and the ratio of cos 90 minus theta. You can see they are the same. So as they have the same relationship in terms of complementary angles, we are going to look at the other trig ratios and their relationship. So for this one, whenever you are asked to find sine theta is the same as cos 90 minus theta. Then when we come to cos theta, it is also the same as sine 90 minus theta. When you come to tan theta, so tan and cot are also having the same complementary angle. So we have tan theta will give you cot 90 minus theta, and cot theta will give you tan 90 minus theta. Then cosec and sec is also having the same complementary angle. Then we have cosec theta will give you sec 90 minus theta, and sec theta will also give you cosec 90 minus theta. So this is the complementary angles in relation to these three ratios. Now let's apply this in our example. So let's take this example. Now we are asked to simplify sine 43 degrees over cos 47 degrees. Now in relation to this, always we are going to get the numerator and the denominator angles, which add up to 90 degrees. Then the relationship between the ratios given to you will also tell you that they have common relationship. So in this case, if you want to solve this, what you need to do is that you need to change either the numerator or the denominator to be in correspond to the other ratio. So we are going to apply the concept of these trig ratios in solving our example. So over here, we are going to say that I'm going to change the sine 43 degrees to be in cos. So over here, you know sine theta. So the theta is the 43 that you see here. So the sine theta will be given as cos 90 minus theta. So I'm not going to write sine 43 anymore, but I'm going to represent cos 90 minus theta, and the theta is known, and that is the 43. So over here, it is going to be cos 90 minus 43 degrees all over. So since I've changed the numerator to be cos and the denominator is already cos, I'll maintain the denominator cos 47 for easily simplification. So over here, we are going to say that cos 90 minus 43 will give you cos 47 degrees over the denominator cos 47 degrees. And you know, when you cancel out this, the result is going to be 1. And this is the result when you simplify this. So you must abreast yourself with the complementary angle principles in relation to trigonometry. Now let's look at the second example. So you are supposed to solve this. So you're going to apply the identities that we have for the complementary angles. Now you know tan is also going with cot. So tan theta is equal to cot 90 minus theta. And cot theta is also equal to tan 90 minus theta. So I'm going to apply this to solve this problem. So over here, I'm going to change the numerator to cots so that the simplification will be much easier for us. And also look at the relationship between the angles here. They add up to 90 degrees. So over here, I have 2 cots 90 minus theta, and the theta is the angle known there, which is 63, over, then I'll maintain cot 27 degrees, minus the same here, cot 90 minus theta, and the theta here is 20. So over here, we have the theta, which is 20, over cot 70 degrees. Now I'm going to simplify this. So we have 2 cots. This will give you 27 degrees over cot 27 degrees minus cot 70 degrees over cot 70 degrees. So we are going to write the final result. Over here, I have, so everything here will cancel out. So we have 2, then also this one is going to be cancelled out. So we have 2 minus 1. So this, when this cancels out, you're going to get 1. This is also 1. So 2 here and 1 here. So 2 minus 1. And your final result is positive 1. And this is the final answer to the problem. All right. So this is what we have for complementary angles in relation to trigonometry. Thank you very much for watching this video. Don't forget to like and share the video. Please go to YouTube and subscribe to my channel. Thank you.